Hi, I'm Tiffany Chong from Ecospheric. In this video tour, we're going to take a look inside the UK's greenest retrofit, the Zetland Passive House project. These Victorian townhouses are the first EnerFit Plus homes in Europe, but we wanted to go beyond the Passive House standard and make them as sustainable as possible. We've built them using only natural, breathable materials, and we've minimized waste and embodied carbon by reusing as many existing materials as we could. On top of that, there's no central heating system and zero energy bills. These houses are 126 years old. The image on the right is from 2016 when we purchased the property. The homes had been converted to shared rental flats decades ago and were not well maintained. They're just one example of the 8 million properties in the UK built before 1930, and they're some of the trickiest formats to upgrade. Our challenge was to bring back that Victorian charm while also meeting Passive House standards and minimizing embodied carbon. As part of that process, we needed to create Passive House standard stained glass windows and doors. We think this may be the first example of Passive House stained glass in the world. Now let's take a look inside. One of the biggest challenges in this project was preserving the Victorian brick facade while also adding on triple glazed windows and cavity wall insulation. We had to painstakingly dismantle the bay walls brick by brick and rebuild them further out in order to accommodate thicker insulated walls. Another thing we did to maximize space was removing the chimney breast. We've used the chimney void to house the ventilation ducting and electrical wiring. And if you're wondering about the energy usage of this beautiful chandelier, it's a refurbished antique rewired to meet low energy standards. All the lighting in the house is LED. The kitchen cabinetry has been handmade using locally sourced hardwood. The timber is waste wood harvested from local parks and green spaces where trees needed to be removed. The worktops are made with Welsh slate, and all appliances are AAA rated for energy efficiency. From the kitchen, we have a view of the dining nook, and beyond that, the rear lounge. The V&A timber supports are one of the most distinctive features of this house, and something we get asked about a lot. We wanted to avoid using steel beams, which have a very high embodied carbon, with inherent thermal bridging issues. Timber is a renewable material with better thermal performance, and triangles provide a much stronger support, so that's why they're there. In the lounge, we have a DIB-T accredited wood stove. It's airtight with a direct air feed from outside the building envelope, which means it won't create drafts by drawing warm air from within the house. You'll notice the back of the house looks very different from the front. We've used pre-fossilized wooden cladding. It's meant to last 50 years without maintenance. Now have a look at the windows. You'll see they've been angled to maximize solar gain. So as we look up, the glazing gets smaller to avoid overheating the upper level. There is no extension on this house. Building extensions means using more materials and always results in more envelope by which to lose energy. So we've adopted tiny house principles to maximize space and utilize it to the greatest effect. We've lowered the floor to create a double height space and offer al fresco access to the garden without need for an extension. We've reused as many existing materials as possible. We kept all the original floorboards, but we did pull them up and relaid them in this chevron pattern. As well, the joists under the floors, the rafters in the roof, the staircase, and over 200 tons of bricks over the two buildings have also been preserved. Here's the family bathroom. The faucets are all gold-plated for durability and aerated to conserve water. The cloakroom toilet on the right recycles gray water, so dirty hand wash water is stored in the basin and used to flush the toilet the next time it's used. On the bottom right, you'll see the copper light switch, which is antimicrobial to prevent the spread of disease. For the walls, we use lime plaster inside and out. The alkaline nature of lime makes it resistant to mold and bacteria. It also absorbs carbon dioxide and combats damp. The interior walls have been finished with a graphene-infused lime paint, which provides incredible crack resistance. So in these two materials, we have airtightness and vapor control. In regards to insulation, we used blown cellulose insulation made from recycled newsprint and wood fiber insulation. The project required 100 pallets of insulation delivered on Arctic lorries. Hidden in the roof and wall buildup is an intelligent building membrane. The Saiga Myrex membrane provides an airtight barrier whilst releasing moisture. The technology uses biomimicry, taking inspiration from the cactus to keep the building fabric dry. This project has always been about pushing boundaries and driving technological change. The Zetland Passive House project is one of the first to install a Mixergy hot water tank. This app-enabled AI-controlled smart tank is able to separate hot and cold water, so it only heats what's needed. The Paul MVHR system has a heat exchanger to retain warm air while filtering out nasty odors, as well as dust and pollen. Both systems, along with all the appliances in the house, are powered by the solar PV panels on the roof. These family homes achieved an air pressure test result of 0.86 air changes per hour and a 95% reduction in space heating demand. If you want to learn more about this project, get in touch. We offer CPDs and consultancy. And if you fancy moving to Manchester to live in a passive house, the building goes on sale shortly.